Good evening, all. So, in the previous class, we studied about the concavity and point of inflection. Another way to find point of inflection is that at the point of inflection, the graph changes its concavity, right? So, basically, we have three methods or three ways to check the point of inflection. So, we'll be taking one example on this, and then we'll move to the last topic, that is graphs. So, small topic will not be a lengthy class. So, there is a function, a polynomial function, degree 4, x to the power 4 plus bx square plus 8x plus 1, and they say that it has a horizontal tangent at a point of inflection. For the same value of x, that means at the same point. Based on this, we have to find the value of mod b. This is the question. So there is some value of x at which f dash x has a fx has a horizontal tangent, and at that same point x, it has a point of inflection as well. So using these concepts, we have to find the value of mod b. So can anyone tell me what is the mathematical meaning of horizontal tangent? How you will use this condition that function has a horizontal tangent?
So the slope is 0.
Yes, correct. So that means it has something to do with f dash x, right? So let us find f dash x first. This is 4x cube plus 2bx plus 8. Also, we need to find point of inflection also, and it is occurring at the same value of x. So point of inflection can be calculated by second derivative test as well. So if we differentiate it for the second time, we will get 12x square plus 2b. And now if you remember, in case of second derivative test, the second derivative should be 0. And for that value of x, third derivative should not be 0. So first of all, let us put f double dash x equals 0. This means 12x square plus 2b equals 0, which means x square is minus 2b upon 12. This implies x square is minus b by 6. So first thing that is clear from here is that b should be a negative number. Why? Because when b will become negative, this minus b upon 6 will become positive, and only then x square will be having a meaning, because we study real valued functions. That is why. So b should be a negative number. Now f triple dash x. F triple dash x, differentiating for the third time, it will come out to be equal to 24x, and clearly it is a non-zero number. Why? Because you are going to use this value of x here, which will be plus minus under root of minus b by 6. And if you put this value here, and you already know that b is negative, that means because of that it is some number, some non-zero number. So that is why we can say that third derivative is non-zero, which is the condition for point of inflection. Now, what else is remaining? Now for these x, that is plus minus under root minus b by 6, f dash x should be 0, horizontal tangent, and at the same value of x, where point of inflection is coming. So let us go back to the expression of f dash x and put it equal to 0 at these value of x. So what is the expression? Expression is 4x cube plus 2bx plus 8 equals 0. So we can do one thing. Either we can put x equals plus minus under root b minus 6 everywhere here in this equation, or what we can do, we can take x common from the first two. This will become 4x square plus 2b plus 8. And instead of putting this value of x, let us put x square equals minus b by 6, because we are getting these values from this expression only. So what will happen? 4 times of this number plus 2b plus 8 equals 0. This becomes, we are still sub we will put x as plus minus under root b minus 6 here as well, but after doing some calculation. So this will become minus 2b by 3 plus 2b equals minus 8. We can shift it there. This will become 4b by 3x equals minus 8. We can further simplify it. Px by 3 is minus 2. And now, instead of putting the value of x, let us square this equation. And now let us put x square once again, which is equal to minus b by 6. Minus b by 6. So this will be better. Instead of putting x equal to plus minus here, it is better that first you put the value of x square and then again square it. That will make calculation easy. So ultimately it is b cube equals minus of this number 54 into 4, that will be 216. And being a cubic equation, it will have 3 roots, but the real root will be only minus 6. And that's it. Therefore, mod b equals 6. So according to the question, at the same value of x, there is horizontal tangent as well as point of inflection. So every condition is satisfied. First, we differentiated it for the first time, then for the second time, and putting it equal to 0 because point of inflection, right? We got some value of x, and when we put it in the third derivative, it is coming a non-zero number. So point of inflection, this is used here. Now what is left? That f dash x should be 0, horizontal tangent. So just put this value of x in the expression, rest is calculation. So from here you will get b as mod b as 6. So either you draw the graph if you are not able to draw the graph, or it is some question which is based on finding some unknown, then you can go for second derivative test, or you can go for first derivative where there is no sign change. So that will depend on the question, that what should be our approach, how we should find point of inflection. Now you have studied so many things in this unit. You studied about the rate measure, then approximation, finding equation of tangent and normal, lengths of subtangent, subnormal, etc., orthogonality, then increasing, decreasing monotonicity of the functions, monotonicity and maxima minima in case of non-differentiable functions as well. All right, then for differentiable functions, then you studied about critical points, finding maxima minima in closed interval, so many things. Then concavity, point of inflection, all these. Finally, whatever you have studied till now will be used to draw other type of graphs which we have not studied till now, like graphs of polynomial function of degree 3, degree 4, because till degree 2 we have learned in class 11th only. Graph of linear polynomial is a straight line, graph of quadratic polynomial is a parabola. Okay, but what about cubic, biquadratic, etc., and some other type of functions as well, like rational functions. Rational functions means division of two polynomials. So let me write first. So graphs of differentiable functions and rational functions. By differential functions, we mean polynomial functions here. So we are going to study about the graphs of different type of polynomial functions as well as rational functions. What are rational functions? Simply division of two polynomials. There may be a polynomial in numerator as well as denominator. Someone asks you to draw its graph, then we are going to use few steps. Based on that, we'll be able to draw the graphs. Each and every step is very important, and the complete knowledge of functions as well as differentiability, continuity, limits, AOD, all is required. So let us write these steps to draw the graphs. Very important article. Many questions are asked these days. We will see how they ask the question in exam. First thing, and this is very obvious step, find domain. First of all, you should be clear that what are those values of x which you can put, right? Only then you will be able to draw the graph. Then find roots. By roots, we mean values of x for which y is 0. Because usually function is of the form y equals fx, right? So what is the meaning of roots? Values of x for which y becomes 0. Then third, find, so limit will be used in third step. Find value of function at x tending to plus minus infinity. Provided these two are in the domain, and they will be in the domain, right? Because infinity and minus infinity, they are always in the open interval. And in polynomials, domain is R. Then you must be wondering why we have written find domain. Because question can come from this type also, like polynomial upon polynomial. Then you will have to find the domain as well. Otherwise, for polynomials, domain is R. So we can skip the first step. Then few points that you have studied in this unit, you will have to find maxima minima. You will have to find concavity of the graph. That can be done by the help of f double dash x. You have to find monotonicity of the function and find point of inflection if any. So from year to year, last 4 points, they have something to do with derivative. F dash x, f double dash x. Mostly f dash x and f double dash x will give you the idea about maxima minima, concavity, monotonicity, point of inflection. Combining these 7 points, you will be able to draw the graph. Now let us use these steps in some question. I am starting with a very basic example. Draw graph of y equals x cube once again. Though you already know how to draw its graph, you might have learned by now. But let us use these steps and then draw graph, okay? Instead of learning it. So first step, domain is R, polynomial function. Second, roots. So for roots, you will put y0. You will get three equal roots. Cubic equation. Three roots, all are same, all are 0. Third, find value of the function at x tending to plus minus infinity. All right. So limit x tending to infinity of x cube and limit x tending to minus infinity x cube. Both of them. First one will be plus infinity, that is infinity cube. Second one will be minus infinity. All right. Then now the last four steps. It is a differentiable function. In fact, we are studying. See, we are studying the techniques to draw graphs of differentiable functions. So here there is no question like discontinuity, non-differentiability, etc. That you already know. In case of discontinuous function, there will be break. In case of non-differentiable, there will be a sharp corner, right? Then fourth, find maxima minima. So now comes f dash x. So f dash x is 3x square. Put it equal to 0. Remember second derivative test. So for maximum or minimum, first derivative must be 0, which is coming at only single value 0. Now you find f double dash. F double dash is 6x. Okay. F double dash x is 6x. You put 0 here, you get 0. And triple dash x is 6, which means x equal to 0 is point of inflection and there is no maxima minima because see only one point is coming 0. So there is no question of fourth step maxima minima. There is no maxima minima. Point of inflection. So fourth and seventh are covered at the same time, which means x equal to 0 is point of inflection. Now two things are remaining, monotonicity and concavity, right? So watch out for these steps. Concavity. So concave up when f double dash x positive, which means 6x positive, which means x positive. That means when x will be positive, shape will be concave up and concave down when f double dash x is negative. That means 6x is negative here, which means x is negative. So now you are getting the picture of the graph. What is happening? Where it is concave down, where it is concave up, where it will cut y x axis, what will be its roots, how will it behave at plus infinity and minus infinity. All these are giving you the picture of the graph. Now, last point, monotonicity, increasing, decreasing. So, monotonically increasing, right? When f dash x is positive, f dash x, remember, which means 3x square is positive. And from here you come to an important conclusion. I wrote that f dash x will be, sorry, function will be monotonically increasing when f dash x is positive, and for that it should be positive. That means 3x square should be greater than 0, which means x belongs to R, except 0. Why? Because 3x square will always be positive, whatever x you put. And at x equal to 0 also, f is monotonic increasing. You can check monotonicity at a point. I told you this. We have already discussed monotonicity of the function x cube at x equal to 0. It came monotonic increasing. How we do it? At 0, we find three values, f0 minus h, f0 and f0 plus h. They will come in the ascending order, where you will put in the expression of the function. F minus h cube, a negative value. F0 is exactly 0 and f0 plus h means h cube, a slightly positive value. So increasing order is there. That means at x equal to 0 also function is monotonically increasing. So overall function will always be increasing. Let us combine all these points. Now we have to draw the graph. So gone are those days where when we used to write some points and we used to join them with scale. That we used to do in straight line. These are not linear curves. Okay. You cannot just arbitrarily join some points and say this is the graph. You have to follow these steps. First thing, domain is R. That means you will find the graph throughout this plane. First thing. Okay. Then roots 0, 0, 0. So only these are the roots, only at one point. Then, okay, at infinity values plus infinity, at minus infinity values minus infinity. That means here and here, these 2 points. I have located this point to show that this is at minus infinity, height is minus infinity, this is plus infinity, height is plus infinity. Then point of inflection 0. That means here concavity will change. And how is the concavity? For greater than 0, it is concave up. For less than 0, it is concave down. And function is always increasing. So that is sufficient to draw this graph. See what is happening. At minus infinity, it is minus infinity. At plus infinity, it is plus infinity. Roots are 0, 0, 0. Function is always increasing. Move from left to right on x-axis. You will always observe the increase in height. This point, 0. Roots are there. What else? Point of inflection. Concavity is changing. What else? To the right, shape is concave up. To the left, shape is concave down. Why? Sines of f double dash x. So together, all these things, they add up to give the graph of the function. Okay. Here there is no maxima minima. So that is why you cannot find any peak at any point. That is why. But actually this particular function, we have already done it so many times. Let us take some another example. Suppose we have to draw the graph of y equals x cube minus 3x. All right. So once again a cubic polynomial, but minus 3x. This term is also present. So just wait, please. Okay. So first thing, domain. Domain is R, cubic polynomial. Second, roots. Put y is equal to 0. You will get three different values of x, and they are x equals 0, and from x square is equal to 3 you will get two roots, minus root 3 and root 3. All right, then limit x tending to infinity. This will be obviously infinity, because see it is something like this, infinity cube minus 3 into infinity. So usually the term having highest power, that will give you the value. Similarly, limit x tends to minus infinity. This will be again minus infinity. Minus infinity. Now maxima, minima and everything. So dy by dx, f dash x. F dash x is 3x square minus 3. Put it equal to 0. Now you will get two different values. X square is 1, x is plus minus 1. So definitely now we are going to get maxima minima. For that, let us find second derivative. F double dash x is 6x. So you are getting these two values, okay? Either they will give you maximum minima or point of inflection. And in this case, they are giving maximum minima and no point of inflection, okay? No point of inflection will be here. F double dash 1 is 6, which is positive. At x equal to 1, minima occurs. Second derivative test. F double dash minus 1, value is minus 6, negative value. At x equal to minus 1, maxima occurs. What type of minima maxima? Local maxima minima. All right. Since they are saying that at 1 and minus 1 some maxima minima is occurring, so let us find the values as well. Okay, values of the function, not the value of the derivative. Since fx is x cube minus 3x, so f1 is minus 2. Remember this is minima. Minima means local minima. And f of minus 1 will be minus 1 cube minus 3 into minus 1, that is 2. And this is your maxima, local maxima, around point minus 1, right? And since f double dash x is not becoming 0 for any of these values of x, so no point of inflection. All right. Now what else is remaining? Maximum minima is complete, no point of inflection. So concavity and increasing, decreasing, those two parts are remaining. So let us come back here. Concavity. that can be explained with the help of f double dash x. Concave up when second derivative is positive. So this is same as the previous part now, previous question. For x positive, it will be concave up. Therefore, concave down when x is negative in the remaining part. What else is remaining? Monotonicity. That will be explained with the help of f dash x. Now f dash x is 3x square minus 3. Take 3 common. This will become 3 into x minus 1 x plus 1. Now you know that function is monotonic increasing. Monotonic increasing when f dash x is positive. This means 3 into x minus 1 x plus 1 greater than 0. Wavy method will be used and you will get this interval as minus infinity to minus 1 union 1 to infinity, right? So in this interval function will be increasing. So naturally in the remaining interval it will be decreasing. Therefore monotonic decreasing when f dash x negative and that is happening in the middle zone. So that means x is varying from minus 1 to 1. So many things. Let us come back. Domain is R. Roots are 0, root 3 and minus root 3. When you will draw the graph, you will locate these points. Then only you will be able to draw the graph. You are supposed to locate 0, root 3, minus root 3 on x-axis as well as 1 and minus 1. You do that only first. Let us draw the plane. Locate the points. You have to plot 0. At some distance you plot 1, then minus 1. Also, near these points you have to plot root 3 and minus root 3. Obviously in the ascending order. Now, once again, the graph will start from somewhere here. At minus infinity, it is minus infinity. At plus infinity, it is plus infinity. Okay, from here to here, graph will go. We have to be careful about so many things. Okay, concavity, increasing, decreasing, maxima, minima, right? Okay, and roots as well. Okay, let us locate the roots. So graph will cut x-axis here, then at 0, then at root 3. These three are the roots. Okay, see this thing first. Function is monotonic increasing when x is from minus infinity to minus 1. That means till the left of minus 1 function is always increasing. How to use this thing? Draw a graph which is increasing. Here. Now at minus 1, you will have to connect 2, 3 things at the same time. This is your increasing part. Also at minus 1, see this. At minus 1 maxima is occurring and its value is 2. This point. Also concavity, see this. The shape is concave downward till x becomes negative, till x is negative. That is why the shape is coming with concavity downwards. Now after this, from minus 1 to 1, see this part, from minus 1 to 1, function is monotonically decreasing. So now graph will come down. And as it will come down, it will cut x-axis at 0 and it will come till here. And at 1, we have already calculated the value. It is minus 2, which is minima also, right? Now, still the graph is concave down. Why? Because graph is concave down till x negative. But what happened at 0? What happened at 0? At 0, you might have not observed one thing. We will discuss about it here only. We actually forgot one point here. We said that there will be no point of inflection. But that is not the way. That is not the correct word to be used here. Why? Because see, if till x positive, for x positive shape is concave up and for x negative it is concave down. So that means something is happening around 0. The graph is changing its shape at x equal to 0 from concave down to concave up. That is why it is point of inflection. But you know what happened? We forgot this thing that f double dash x becomes 0 when x equals 0. and at x equal to 0, f triple dash x is 6. Okay, f triple dash x is 6. So obviously point of inflection is also there. We forgot this part. X equal to 0 is point of inflection. And how we came to know that we were doing some mistake? Because if the shape is, if the graph is changing its concavity, definitely that point is point of inflection. Now, what I said, from minus 1 to 1, the shape is, the graph is monotonically decreasing. That is why the height is constantly coming down. Then there is minima at 1. After this, what will happen? Come back to the upper branch, this one. 1 to infinity is there. Shape will again increase. Sorry, height will again increase. Monotonically increasing. Monotonically increasing. And throughout positive x, shape is concave up. No more change in concavity. So that means it will go like this. And it must cut x axis at root 3. Why? Because root 3 is the square root of 3 is actually the root of this polynomial, and it will go like this. So you can look at this point here. That is not an issue. Ultimately, this is the graph. This is the graph of y equals x cube minus 3x. Domain is R. Now suppose I have the graph first. I have been given the graph and I have to read the graph. How you will read it? You will see the graph and you will say that domain is R. No x is missing. Okay. Then at minus infinity, height is minus infinity. At plus infinity, it is infinity. Then you will say that the roots of this polynomial are minus root 3, 0 and root 3 because the graph is cutting at these 2 points. Then at minus 1, it is maxima, local maxima. Local maximum value is 2. At 1, it is local minimum. Local minimum value is minus 2. At 0, concavity is changing, so it is point of inflection. Also, to the left of 0, it is concave down, and to the right of 0, it is concave up. And finally, the graph is increasing till x equal to minus 1. Then it is decreasing from minus 1 to 1, and then again it is increasing from x greater than 1. So these many informations, okay, are available from the graph, but that you should have in mind. You should keep in mind the maximum, minimum, monotonicity, point of inflection, okay, all these points. And don't forget that point of inflection thing, okay, otherwise there may be a confusion. Now see, based on this question only, I am going to tell you what how they ask question in exam. So now we have learned this graph. So see, question can be like this. Just a minute. So the question is, Alicia, you send me some questions one day. Actually, we have not completed the theory till then. Now I'm taking that question. Actually, it is exactly the same question that I would have taken as class example. The number of values of k for which the equation x cube minus 3x plus k equals 0 has two distinct roots. Has two distinct roots lying in the interval. Roots lying in the interval 0 to 1. And the options are A 3, B 2, C infinitely many, and D option is no value of k. So if you can draw the graph, then it is just a matter of seconds. So what we are going to do? What is the question? How many values of k are there, which we put in this equation will give two distinct roots in this interval. Okay. So what we do in such type of questions? From the given equation, we can write it like this. We will transpose k to the right hand side, and from here we are going to draw two graphs. Let let us draw graph of. So this is one old concept we studied in functions. If you have an equation where fx equals gx and they want you to find number of solutions, you draw graph of y equals fx and y equals gx on the same plane, and you see that at how many points both the graphs are cutting each other. So it is something like that. Let us draw graphs of y equals xq minus 3x and y equals minus k. So this we have just learned. We will draw it now. And y equals minus k. This graph is a straight line, horizontal straight line. Like for example, y equals 5. Y equals 5 means we will draw a horizontal line. This is related to coordinate geometry. It will pass through 0, comma 5. It will be parallel to x-axis. Suppose you want to draw y equals minus 2. It will once again be a horizontal line. It will pass through 0, comma minus 2 like that. So y is equal to minus k. It will be a horizontal line. So let us draw the graphs. Y equals x cube minus 3x. Now we have already learned it. So let me draw it. The shape will be something like this. And the points are minus root 3, 0, root 3. This is 1. This is minus 1. This height came 2. And this is minus 2. Now on this plane only, we have to draw graph of y equals minus k. So the question is, how should we draw the graph so that this equation has two roots in two different roots in 0 to 1. 0 to 1, that means interval of x from here to here. This part, see this part. So if the equation has to have two roots, two different roots in 0 to 1, what should be the value of k? This is the question. Okay. So what does it mean? It means that it means that these two graphs should intersect each other at two different points in 0 to 1 interval. Okay. So just a minute. See, when I draw this line y equals minus k, let me draw it with another color. If I draw this line here, listen carefully. If I draw this line here, then you know what will happen. Till just above this height 2, just above this height 2, see this height 2. Whenever I will draw this line, whenever I will draw this line above this height, I will always get only one root, and that will be this point of intersection. Whenever I draw the graph above height 2, I will always get one point of intersection or one root. Same is true if I draw line here. Here also I will get only one root below height minus 2. So only one root. They are asking about two different roots, right? So this zone is not possible. If if I draw a line like this, if I draw a line like this, especially in this zone which is between heights minus 2 to 2, then I will be getting three roots. See this. Always it will cut this graph at three places. But as I'm saying again and again, they want us to find two different roots. So I think only one possibility is there when the line is drawn like this. See this yellow line. This yellow line is clearly this yellow line is clearly meeting this yellow line is clearly meeting this graph at 2 points. One is here and the other point is here. And same can be drawn here. Same can be drawn here. 2 points. Okay. Now if we look at the question says that what are the values of k for which this equation has two distinct roots in the interval 0 to 1. See, interval is of values of x. So when x is from 0 to 1, can this equation have two distinct roots? Or can these two graphs intersect each other at 2 points? What you have to say? Can anyone tell me what will be the answer? The options are 3, 2, infinitely many, or no value of k. What do you think? In the interval 0 to 2, sorry, in the interval 0 to 1, the graph and this line y equals minus k, they are cutting each other at how many points? You consider any line. All these lines, the blue line or the yellow line, they are representing y is equal to minus k. For different values of k, there will be different lines. Okay. But can you tell me that whether this line and the graph are meeting at 2 points in the interval 0 to 1 or not? Is it possible? Or even if you draw this line also, like if we put k equal to 0, it will become y equal to 0. See what is happening. Whenever the line is drawn above height 2 or below height minus 2, it is cutting this curve at only 1 point. In the zone between heights minus 2 to 2, the line y is equal to minus k and the graph is cutting at 3 points. And there are two specific values of k. See this yellow line. You know what will be its equation? Its equation will be y equals 2 and its equation will be y equal to minus 2. So from here I can say that minus k is equal to 2 or k is equal to minus 2. So it looks like we are getting two values of k. We are getting two values of k, that is minus 2 and 2. But still it is not the answer. Though we are getting two roots as I am representing by the yellow dots. But still I will say the answer is no value of k. Can you tell me what is the reason?
So, because we
Yes,
need two roots in the interval 0 to 1.
very good. Because see, consider only this part. You are not just supposed to look for the 2 points of intersection. See this portion which I am underlining right now. This stretches from 0 to 1. You consider any blue line or any yellow line or any other line which is of the form y is equal to minus k, you will never find 2 points of intersection. So what is the meaning of this? The meaning of this is that no value of k for which this equation has two distinct roots in the interval 0 to 1. Now suppose in the same question, let us extend this question. Suppose I remove this interval. Now the question is something like this. The number of values of k for which the equation this has two distinct roots. That's it. Lying in the interval, let us cut this part. Suppose it is some new question. Has two distinct roots. Now can anyone tell me what is the answer? No more interval. So for how many values of k this equation has two distinct roots?
2.
Two values, definitely. And what are those values? Those values are k is equal to 2 and k is equal to minus 2. Okay. Now I can make another question from here. The number of values of k for which the equation, the number of values of k for which the equation this has three distinct roots. Has three distinct roots. No more interval. Has three distinct roots. What will be your answer? How many values of k are possible? Sorry. Let me do one thing. Let me draw the graph once again. So with this question only you will be able to understand everything. Don't worry. Just wait. Suppose I draw this graph once again. Now you know all the points, right? This is 1 minus 2. This is minus 1, 2. And actually these are only important. All right. Now suppose the question is that x cube minus 3x plus k equal to 0 has three distinct roots. Three distinct roots. Find k. Suppose this is the question. So that means what we will do first? We will first shift k to the right hand side. Then as usual we will draw two graphs. One is already drawn. Next one is a horizontal line parallel to x axis. But I need to draw it in such a way that it cuts the given graph at 3 points. So naturally it is this zone C between these two heights. Now draw any number of lines. Draw any number of lines. This can be the line for our answer because it is cutting this graph at 3 points. Same is true for this second line. This is also cutting the graph at 3 points. Same is true for this one. Same is true for this one also. See 3 points. Even values are coming. Minus root 3, 0 and root 3. Same is true for this. Same is true for this. Till here and till here. So all these parallel lines or blue lines, they will always give three roots. So from here, can anyone tell me? We have to find values of k. So can you suggest me what will be the values of k? Sorry, what will be the values of minus k? Because we are drawing the graph of y equals minus k. So this can be y equal to minus k. This can be y is equal to minus k. All of these are of the form y equals minus k. But what exactly are the values? See, no problem at all. Minus k will vary from minus 2 to 2. Why? This minus 2, this is y coordinate. This 2, this is y coordinate. And minus k, this is also y coordinate. So when we draw lines from here to here in this zone, from here to here, k will be varying. K will be in interval. It will be from minus 2 to 2. And based on that, what will be the value of k? For that, you multiply by minus 1. And actually, an interval will be coming. Whenever you take a value of k from this interval and you put it here, and then you solve this equation, you will get three distinct roots. So, how many values are we getting? Infinitely many values. Now, there can be a question that this is the equation and it has one real root only. It has one real root only. Same question. Instead of three distinct roots, one real root. Can anyone tell me what will be the values of k now? If for one root, what will be the values of k? See, in that situation where we can actually draw the line, if we have to find only one root, it will be above this height too. See, all these green lines, they will always be cutting graph at 1 point, and same is true for the height below minus 2. So you will say that for one root, this height minus k, either it will be greater than 2 or this height minus k will be less than minus 2. And based on that you will get the interval of k, and that will be minus infinity to minus 2 union 2 to infinity. And if in the same question they ask you that this equation has two roots, then the answer will be, for two roots, you know where you will draw the lines. We have already discussed. Minus k can be exactly 2 or it can be exactly minus 2. So from here you will be getting two values of k, that is plus minus 2. In such a way these questions are asked. Okay. Some unknown will be introduced. You will be given the idea about the number of roots. On the basis of that you will have to find the value of that unknown. It may be a single value, it may be two, three values, or they may be even in some interval. Okay. So the approach is graphical approach. Okay, then some other type of questions based on this that are asked in the exam. Like for this kind of example we have already taken. Find number of solutions. Find number of solutions of the equation e to the power x minus 8 plus 2x minus 17 equals 0. This question. See, this is totally a case of transcendental equation. Transcendental equation means equation which contains algebraic as well as non-algebraic terms. Like for example, if we have to find the number of solution, they do not want you to solve this equation. You cannot get value of x. You can only tell that these will be the number of x which will be satisfying this equation, and that can be done only graphically. So we have two methods. One is you shift similar kind of terms to one side. So algebraic on one and exponential on the other. Now, as we were discussing, draw these two graphs on the same plane and see at how many points they cut each other. Y equals e to the power x minus 8. We have already discussed the shape is like this. But this is the graph of e to the power x. So how it is the graph of e to the power x minus 8 as well? Because there will be no change in the shape. It will be just the change in the height like this. So it will be the graph of e to the power x only, but it will be suppressed in height by 1 upon e to the power 8 times. So that means in case of e to the power x at x equal to 0, height used to be 1. Now it will be 1 upon e to the power 8. But overall shape will be remaining same. And the second one, this is a straight line. We already know how to draw the graph. At x equal to 0, see at x equal to 0, y is 17. It will be quite above this point, 0 comma e to the power 1 by 8. It will be a very small number, 1 upon e to the power 8. And y will be 0 when x is 17 by 2. You have 2 points, join them. You will get a straight line and you will get a point of intersection as well. So it will be one solution. Because in the question they are asking us to find the number of solution. However, there is no use of differentiation here, right? So let us take method 2. If someone is not shifting these terms on the right hand side, then what could be? Let us take this whole expression as some function fx. So now we have studied limit, continuity, differentiability, everything. So very easily we can see that it is a differentiable function. It is continuous because exponential is always continuous. Then 2x 17. So no problem. Defined everywhere. Continuous, differentiable as well. Okay. Just do one simple thing. Find f dash x. Find f dash x. Differentiate it. So it will be e to the power x minus 8 only. No change. X minus 8 is differentiation will be 1. So though we can use chain rule, but not of much use here. Then plus 2. We differentiated this expression, we are getting f dash x is e to the power x minus 8 plus 2, which shows that f dash x is positive for all x because it is e to the power some number plus 2, which is definitely positive. So that means it will always be increasing. Very important. It will always be increasing. That means it will never come back, down. Okay. The graph will constantly be increasing. So if it is constantly increasing and the domain is R, let us find two values and that will help us to draw the graph. That is minus infinity and infinity. Who can tell me the answer of the first part? When x is tending to minus infinity, what will be the answer of this limit? Can anyone tell me? Because that will help us to get the answer. E to the power x minus 8 plus 2. When x tends to minus infinity will be equal to how much?
So 2.
Yes, correct. Good. So 2. Why? Because when x is tending to minus infinity, this will be like e to the power minus infinity plus 2. And this part is 0. We have discussed so many times. E to the power infinity is infinity only. Number greater than 1 to the power infinity and this thing becomes 0. And what about the second part? Second part will be infinity. Second part will be infinity, right? Because at x tends to infinity, e to the power infinity is infinity. Infinity plus 2 will be this only. Okay, wait a minute. Wait a minute. Sorry, just one mistake here. Actually, I am taking limit of the derivative. We are not supposed to take the limit of the derivative. We are supposed to take the limit of the function. If you remember, we have to take limit of the function. Sorry for that, and let me remove this. So I took the limit of the derivative. But still this limit thing was okay. That will be used once again. Okay, so limit of fx e to the power x minus 8 plus 2x minus 17. Yes. Now can you tell me? See, let me tell you this value. This value will be minus infinity only. Why? This first part will become 0. E to the power minus infinity, this is 0. Then 2 into minus infinity will be minus infinity minus 17. So a negative infinity. And if we want to find its value at plus infinity, then it will be plus infinity. E to the power infinity itself will be a very big number. So this is sufficient to explain. And you can take one more number here. You can take one more number here, that is 0. So that will give you an idea where it will be cutting y-axis. So when you put x equal to 0, see, put x equal to 0 here, you will get e to the power minus 8 minus 17, a negative number. Do not find its exact value, that will not be possible, but you get an idea that it is a negative value. Based on this information, which is here on the page, you will be able to draw the graph very easily. This is the graph. Why? What is this point? At minus infinity, you are getting minus infinity. At plus infinity, you have plus infinity. Graph is strictly increasing because f dash x is positive, and at 0 also it is negative value, this part. So this is sufficient to tell that the graph will be cutting x-axis at one point. So this will be one solution. So what do you observe? These are two different approaches, right? In one approach, I'm shifting a similar kind of terms on one side and another kind of function on the other side. We draw graphs of both these functions and we see where they cut each other. In this approach, we are not shifting anything else. We are considering this whole as a single function. We observe its monotonicity. We observe that it is throughout increasing. Then we calculated values in the domain extreme values, and just for our convenience, we calculated f0 as well. And this gives us an idea that it will be cutting x-axis at one point. Why this is the solution? Because what is the meaning of this thing? That when you will put this x here, the value will become 0. That is what you are calculating, roots or the number of values. One more thing you might have observed, that here the shape is concave up. I have drawn the shape which is concave up. It is not my choice. It is because of f double dash x. Find second derivative. If you will differentiate for the second time, you will get e to the power x minus 8, which is positive for all x. That is why the shape is always concave up. Okay. Two approaches. Okay, so finally I have last question for you, and that will complete this chapter as well as this unit, differential calculus. Now after today's class we are going to meet on 18th or whatever after Diwali vacations. Okay. So during these holidays, please complete your backlog and those question banks. I am repeating, I think, for the third or fourth time. Maximum, minimum, tangent, normal, and monotonicity. If you want to discuss, I can, provided you complete those assignments, and then we can start discussing. And we will start with integration from the next turn. Okay. So last question for today: how many real solutions? How many real solutions does the equation x to the power 7 plus x to the power 5 plus 16x cube plus 30x minus 560 equal to 0 have? And the options are 7, 5, 3, 1. Okay, before we solve this question, I have few questions for you. First question: can anyone tell me why there is no option like 8 or 9 or 10 or let's say 100? Why the options are like 7, 5, 3, 1? Why not there can be an option like where I put in place of D option, in place of 1 I write 90 roots or 17 roots or 100 roots? What could be the reason? Why the highest term appearing here is 7?
So the
Powers.
Yes, degree or power, correct. So a polynomial equation of degree n can have at most n real roots. First thing, it cannot have 8 roots or 9 or 10. If someone is saying that there is a equation of degree 7 and it has 9 roots, then he is trying to confuse you by saying that the equation is identity. You will not say that he is saying wrong. He will just give you the information indirectly. Whenever the number of roots are higher than the degree of the polynomial equation, it becomes an identity. Okay, that is another thing you might have studied in quadratic as well. So maximum can be 7. That is fine. Now my second question is why they are giving real solution number of real solutions as 7, 5, 3 or 1. Why not 2 is here? Why not 4 or 6? What could be the reason? Why even numbers are not present? Is just a coincidence or there is some reason behind it? Yes, any one of you. Why not any even number option?
so because the
Yes,
imaginary roots are always present in pairs.
good. This is the reason. Because see, this 7-degree equation either it can have 7 real roots or it can have 5 real roots and 2 non-real roots because non-real roots occur in conjugate pair. Or it can have 3 real roots and 4 non-real occurring in conjugate pair. Or either it can, finally it can have 1 real and 6 non-real. It cannot have 4 real and 3 non-real. This can never happen because the complex number, third complex root, it is not having conjugate pair. So that is not correct. Okay. Now, let me tell you how to proceed. If you are thinking that you will solve this equation and get all the roots, then forget about it. Okay. No one solves 7-degree equation ever. Then why they are asking about the number of real solutions? Because we have studied application of derivatives. So I am finding f dash x. It is 7x to the power 6 plus 70x to the power 4 plus 48x square plus 30. Just after writing this particular step, I can get the answer. Immediately after finding f dash x, I will be able to give the answer of this question. Can anyone explain the answer with reason? Why just dash x I am able to give the answer? What do you think? Okay, tell me, after observing f dash x, what type of function fx becomes? What about the value of this f dash x? Can anyone tell me? See, it is very simple to observe that f dash x is positive. Why? All the even powers are there. Squared, power 4, 6, then plus is there. Still 30 is also there. So even if the first three term becomes 0, still you will get 30. So it is positive for all x belongs to R. That means function is always increasing. It will never attain the same height which it has already attained. It is always increasing. What else? Now just have a look at the highest power. This will give you an idea. Limit x tends to minus infinity of fx. It will be minus infinity because odd power is there. Limit x tending to infinity fx. Now you will get plus infinity. And for convenience, find one more value f0. That is minus 560. Draw the graph. You will get the answer. 1. Why? At minus infinity, we have minus infinity. At plus infinity, we have plus infinity. At 0, it is this. And this will be the graph once again. Because at 0, we are getting a negative value. See, the markings are not up to the scale, but that is not important. You might wonder how minus 560 is so close to origin. So, but we are not interested in exactly marking like 0, 1, 2, 3, and all. Just want to show that this value is negative, okay? And it is strictly increasing. So, one root, that's it, finish. And why the shape is concave up? For that, you can find f double dash x and see yourself, okay? But that is not required actually. Try to understand one simple thing. Graph is starting from minus infinity. It has to go till infinity. It will never achieve its height whichever it has attained once. Okay. And that is why whenever it will cut x axis, it will never come back. Why? Function is increasing. Alright. So this is the reason. That is why it will be having only one root. Now, if someone says, "Sir, what about three roots?" Then for three roots, definitely it has to come up and down and again up, something like that. So for three roots, function can't be strictly increasing, right? Same is true for five roots or seven roots. So this question was asked in JEE main. So those who have no idea about application of derivatives, they will think that we have to solve and then find. So that is not possible. Okay, solving 7-degree equation, we are able to find maximum. We are able to solve maximum 4-degree equation. That also in particular cases. And for cubic, we find one root by hit and trial. You all know, all of you, about this thing. Quadratic equation you have already completed. So degree 5, 6, 7 equation. Forget about solving them. So this is it. We have completed this unit. Okay. Do the homework as I have repeated again. That's it for today. Thank you and happy Diwali to all of you in advance. Bye everyone.
Thank you, sir.